Okay, so collisions, explosions, and impulse sounds quite exciting. It's not the same as explosions in chemistry, I'm afraid, but it's still quite cool. There's a few more equations that you're going to come across that you haven't done before, but a lot of it is sort of expanding on Newton's laws. So it's expanding on physics that you do already know. So we've got principle of conservation of momentum, and we have momentum, which is known by a P for some reason, is m times v. We're going to use a kinetic energy equation again, so we're all familiar with half mv squared. And there's also this one at the bottom, ft, so force times time, is equal to the change in momentum, so m times final velocity minus m times initial velocity. All will become clear when we go through them. So we're going to start off with the original, just what is momentum. So in a collision, there are two factors that affect the amount of damage which occurs to the vehicles involved. So can we guess what they might be? Yep, speed and mass, or velocity and mass. So obviously, if you're going really quickly, then there'll be more damage. And also, if it's a bigger vehicle, so obviously crash into a lorry, there's going to be a lot more damage than if you crash into a bike. Okay, so momentum is the combination of those two things. So momentum is a measure of the amount of motion of an object and is defined as P for momentum. And momentum units are kilogram meters per second. Because momentum is mass times velocity, so it's the units of mass times by the units of velocity. M is mass in kilograms, and V is velocity in meters per second. So velocity is a vector, so momentum depends on velocity, so momentum is also a vector. So direction is important when we're talking about these. And it will become quite important when we start doing questions based on these, because you need to be able to work out which direction things are going after crashes. So things might be going towards each other and move away from each other, or things might carry on going in the same direction. So it's important to think about that. An object can have a large momentum because it's either got a large mass or a large velocity, or both, obviously. So an oil tanker might be going quite slowly, but because of its huge mass, it's still got a large momentum. Or a shell, so a bullet from a gun, will also have a large momentum because it's got a large velocity, even though it's got quite a small mass. So it does depend on mass and velocity. A reminder about your kinetic energy. I'm not going to label all those values because you should know what they are. Kinetic energy in joules is half times mass in kilograms times speed squared, so meters per second squared. And it's an energy, so it's a scalar quantity. So an object has a kinetic energy because it's moving, but it doesn't matter which direction it's moving in, it's still got that movement energy. Okay, so it's just a scalar. So two equations, half mv squared is your kinetic energy, and your momentum is mass times velocity. So for example 1, a 2 kilogram ball moving at 4 meters per second hits a wall and rebounds at 3 meters per second as shown. So starts off at 4 meters per second and then rebounds at 3 meters per second in the opposite direction. So first of all, calculate the momentum after the collision. So again, it's always handy to think about which direction are you going to say is positive. And usually we just do it automatically. We say the original direction is positive, which would be the right-hand way. So the way that it's originally going. So momentum is mass times velocity. So the mass is 2 because it's a 2 kilogram ball, and the velocity is going in the opposite direction, so it would be -3. So yes, correct. It'll be -6 kilogram meters per second. And it's just always nice to finish writing that off, writing a sentence just to say what that means. So the momentum is 6 kilograms per second to the right, or in the opposite direction of the original movement. And B, I'm sure you guys can do that without my help. So calculate the kinetic energy before the collision with the wall. So half mv squared. So before the collision, traveling at 4 meters per second. So I'll let you guys do that. I will write it on the board while you guys do that. Oh, yeah, sorry, to the left. Yeah, thank you very much for pointing that out. I'm obviously still slightly ill because I can't tell my left from my right. So you should be getting 16 joules.